Modo's particle and dynamic systems are an extension of Modo's rigging system. They are node-based and brought together in the schematic viewport or via a selection of buttons in the UI. When working with particles, a range of different emitter types can be utilized, including radial, surface, curve, and source. These can be brought into the scene and then influenced by a range of forces like wind, curve, and turbulence. And in turn, these can be influenced by a range of fall-offs that will modulate their effect. Simulations can be viewed in real time, either in isolation or in the context of the scene, and particle simulations can either be cached and saved with the scene or saved as a CSV file to improve scene efficiency and allow for the simulation to be shared. For more complex simulations, particle operators can sample aspects of a simulation, and those values utilised in other parts of a network. And for quick access to some pre-assembled simulations, Modo comes with a number of presets that you can quickly add to a scene. Particle simulations can also be converted to geometry. This allows you to make subtle adjustments to the paths of any particles with Modo's particle sculpting tools, and even remove specific particles if required before applying those changes back to the original simulation. Modo also comes with a range of particle modifiers. These are particularly useful for generating procedural effects for motion graphics, for example randomly changing the position of a particle based on an audio file. Modo also supports both rigid and soft body dynamics, allowing objects to interact with each other in the scene. Both rigid and soft body objects will respect the same forces that affect particles, and you can restrict the movement of objects in a number of ways by using a range of constraints. If you want to destroy an object, the shatter and glue command will break an object into a number of pieces ready for simulation, and the applied glue setting will define the amount of force required to break it apart. Curves can also become part of a simulation. By default, they'll act like a fibrous object, which is ideal for simulating hair or rope, but they can also be treated as a compound object, making them ideal for simulating chains. Because PMODs and emitters generate point clouds, they can be easily utilized by replicators. One of the most powerful parts of the dynamic system is its ability to respect the volume of replicated objects. By incorporating a dynamic replicator into the schematic, an enormous number of objects can then be involved in a rigid body simulation. Modo's Dynamics toolset is another great example of the holistic way in which it treats scene creation. It has all the tools that you need to knock down some bookshelves, turn an object into jelly, or to simply blow up a building.